Hello students, today we are going to study class 8 science chapter 6, that is combustion and flame. So let's start the chapter. People generally use wood, cow dung cakes, crop residue, kerosene oil, coal or LPG gas to cook food. For running vehicles they use petrol or diesel oil. In factories we use coal or fuel oil or natural gas. The materials such as wood, coke, LPG, petrol, diesel, they all have one common property, that is they produce heat on burning, which is then put into different uses. Furthermore, some materials on burning produces flame and some do not. For example, a candle or coal gas on burning produces a flame but not the coal or charcoal. So let us study the chemical process of burning and the types of flame produced during the combustion process. So let's start with combustion. A chemical process in which a substance burns in oxygen to give off heat and light is known as combustion. As already we have done activity burning of magnesium ribbon in previous classes. So the examples of are burning of magnesium and charcoal. These are the example of combustion. Since both give heat and light on burning, thus magnesium and charcoal are combustible in nature. So it is not essential that light must be produced in combustion. So what are the different types of substances? So we can categorize all the substances into combustible and non-combustible substances. So what are combustible substances? Substances that burn easily in air or oxygen to produce heat and light, which may or may not be produced, are called combustible substances. What are non-combustible substances? The substances that do not burn in air or oxygen are called non-combustible substances. So what are the examples of combustible and non-combustible substances? Coal, wood log, wax, cloth, coal, charcoal, natural gas, kerosene, diesel, all these examples of combustible substances. What are the examples of non-combustible substances? Iron nail, glass, stone piece, steel spoon, water, brick are the examples of non-combustible substances. So what are the different types of combustion? Depending upon the conditions under which combustion takes place, there are three types of combustion. So depending upon the types of condition, there are three types of combustion: rapid combustion, spontaneous combustion and explosion. So let's start with the rapid combustion. So when a combustible substances burn at a rapid rate, producing a very large amount of heat and light in short period of time, it is called rapid combustion. That means when combustible substance burns at a high speed in a short time and produces very large amount of heat and light, it is called rapid combustion. Examples are: LPG start burning immediately when a burning matchstick is brought near it. It produces heat and light. Burning of wax candle is also an example of rapid combustion. Another is spontaneous combustion. When a combustible substance burns on its own without the help of any external heat, it is called spontaneous combustion. That means when any combustible substances burn without the help of external heat, it is called spontaneous. Examples are burning of white phosphorus, fire in coal mines and forest fires. What is explosive or explosion? Combustion reaction that occurs suddenly with the evolution of large amount of gases, heat, light and sound is known as explosive combustion or explosion. Example: when we light firecrackers, explosion occurs with the evolution of heat, light and sound. So what are the conditions necessary for combustion? Three conditions which are necessary for combustion are the presence of combustible substances, the presence of a supporter of combustion, and attainment of ignition temperature of the combustible substances. These three conditions necessary for combustion are also called the triangle of fire. This is also known as triangle of fire. So what is ignition temperature? The lowest temperature to which a substance must be heated to catch fire and start burning is called its ignition temperature. That means ignition temperature is the minimum temperature to which a substance must be heated. And different substances have different ignition temperature. So now let's start one activity that oxygen is necessary for combustion of a substance. For that we require a candle, matchstick, a glass tumbler and a plate. So what is the method? We will light a candle on a plate and cover the burning candle with a glass. We will observe that the candle stops burning after some time. The candle burns as long as the oxygen is present in the inverted tumbler. The supply of fresh air to the burning candle is cut off by the inverted tumbler. When all the oxygen of the air present inside the tumbler is used up by burning, the candle stops burning or it gets extinguished. That means oxygen is necessary for combustion to take place. So what are inflammable substances? So the substances which have very low ignition temperature and can be easily catch fire with a flame are called inflammable substances. Examples are petrol, alcohol, LPG, dry grasses, paper, etc. So how do we control fire, or what is fire fighting? Fire at homes, shops and factories can be very disastrous and often cause loss of life and property. So the fire should be brought under control and extinguished as soon as possible. Firefighting means to control and extinguish the unwanted fire. So fire can be controlled by removing one or more of the conditions required for combustion to take place. Already we have discussed the 3 conditions required for the combustion. So we have to remove 1 or 2 conditions. Since it is not possible to remove all the combustible substances from the place of a fire, so the firefighting operations work mainly on the 2 principles. So what are the 2 principles? Bringing down the temperature of the burning substances below its ignition temperature and cutting off the air supply to the burning substances. Next is fire extinguisher. We are going to study about the fire extinguisher, water as a fire extinguisher. So if a fire breaks out in a houses or in a neighborhood, the first thing we must do is we must call the fire service by dialing 101. That means we should call the fire service by dialing 101. So what happens when they come and start throwing water under pressure on the fire? So when water is thrown on the fire, it cools the combustible substances below its ignition temperature and prevents the fire from spreading. The water, when heated by fire, forms vapor which surrounds the combustible material and helps in cutting off the supply of air. So the fire gets extinguished. Thus water is very effective in firefighting operation. So here we can see a fireman extinguishes the fire by throwing water under pressure. As he threw water on the fire, it cools the combustible substance below its ignition temperature and prevents the fire. But there are limitations of water extinguisher. So what are the limitations? First limitation is water cannot be used to extinguish fires in case of electric wiring caused by electrical short circuit. That means we cannot use water extinguisher to extinguish fires in case of electrical short circuit. So what is the reason? It is because water is a conductor of electricity. When it is poured over burning electrical wires or appliances, it causes electric shock to the people involved in the firefighting operations. This electric shock can even kill the people. Second limitation is water cannot be used to put off fires caused by burning of oil or petrol, because water being heavier than oil settles down at the bottom. Oil floats over this water and continues to burn. Second type of fire extinguisher is carbon dioxide as a fire extinguisher. So carbon dioxide is the best fire extinguisher for fires involving electrical equipments and inflammable materials like petrol and kerosene. So carbon dioxide, being heavier than oxygen, surrounds the burning combustible substances like a blanket. As we know that carbon dioxide is heavier than oxygen, so it surrounds the combustible substances like a blanket, and it cuts off the contact between the burning combustible substance and oxygen supply and brings down the temperature of the fuel, and hence the fire gets extinguished. The added advantages of carbon dioxide is that in most cases it does not harm the electrical equipments. So what can we do to take care of fire victims? So first, we should immediately bring out the fire victims from the fireplace to an open space to prevent the fire victims from breathing harmful gases like carbon dioxide or smoke, which may lead to suffocation and breathlessness. When the clothes of the person catch fire, the person should be covered with a blanket. Blanket helps to cut off the supply of air. Hence, the fire gets extinguished. We should pour water over the victim's body. The body will cool down below its ignition temperature and hence the fire gets extinguished. Water also prevents the formation of blisters on the skin of the fire victim, and we should immediately call for an ambulance from the nearby hospital and send the fire victim to the hospital for further medical. A flame is a region where combustion or burning of a fuel in its gaseous form takes place to produce heat and light. So all the gases like LPG which undergoes combustion or burning produces a flame. When we light a candle with a matchstick, the heat of the matchstick not only melts the wax but also changes wax into wax vapor. This wax vapor reacts with oxygen or air and then catches fire to produce a flame. Solid fuels like wax and camphor which vaporizes on heating burn with a flame. On the other hand, coal and charcoal are solid fuels which do not vaporize on heating, so they are burned without producing flame. So what are the different zones of a candle flame? A candle is made up of paraffin wax which consists of higher percentage of carbon. Paraffin wax vaporizes and burns on heating. A candle flame consists of three main zones depending upon the amount of air it receives. These zones have different colors and temperature. So let us start with the innermost zone. This zone lacks oxygen and hence in this zone least or no combustion takes place. So it appears black. It contains unburnt wax vapor. The innermost zone is the least hot part of the flame. In other words, we can also say that innermost zone is the least hot region of the flame. So why it is the least hot region of the flame? Because it is not getting sufficient oxygen. Next is the middle zone. In this zone, there is not enough air for complete burning of the wax vapor. The partial or incomplete burning of the wax vapor produces carbon particles and carbon monoxide. So here there is incomplete burning of wax vapor. The unburnt carbon particles become hot and emit yellow light. So it is the glow of hot carbon particles which makes the middle zone of a flame luminous. These carbon particles then leave the flame as smoke and shoot. The middle zone of a flame is not so hot. So this zone is a major part of the candle flame. And the next is outermost zone. In this zone there is a plenty of air around it. So complete combustion of wax vapor takes place, producing carbon dioxide and water vapor. It has the highest temperature in the flame. In other words, it is the hottest zone of the flame. The outermost zone is quite thin and non-luminous. At the base of a wick, there is a oxygen-rich region where carbon monoxide burns with a blue color, and this region of flame is known as blue zone. Goldsmiths blow the outermost zone of the flame with a metallic blowpipe for melting the pieces of gold and silver into desired shape to make jewelry. When air is blown through blowpipe into the flame, it helps in the rapid combustion of unburnt fuels and hence makes the flame hotter sufficient to melt gold and silver. So what are the different types of fuels and what is fuel? The material which are burnt to produce a large amount of heat energy are known as fuels. Wood, coal, LPG, kerosene, diesel and petrol are all examples of fuels. Fuels play an important role in our everyday life because they are used in homes, vehicles and industries. So how can we classify fuels? Fuels are classified on the basis of their physical state in which they occur. So fuels are classified as follows. Number first is solid fuels. Solid fuels exist in solid state at room temperature. Examples are coal, coke, charcoal, wood and paraffin wax. Another is liquid fuels. Liquid fuels exist in liquid state at room temperature. Examples are kerosene, petrol and diesel. Another is gaseous fuels. Gaseous fuels exist in gaseous state at room temperature. Examples are liquefied petroleum gas, CNG and biogas. So what is calorific value? All the fuels produces heat and heat energy on burning. Different fuels produces different amount of heat on burning. Some fuel produces more heat while other produces less heat. So what is calorific value? The amount of heat energy produced on complete combustion of 1 kg of a fuel is called the calorific value. The calorific value of a fuel is expressed in kilojoule per kilogram. It determines whether a given fuel is a good fuel or a not. Here we can see a table. Calorific value of some fuels are given in this table. So what are the characteristics of an ideal fuel or good fuel? So an ideal fuel should have the following characteristics. It should be fairly cheap and easily available. It should be easy to handle, safe to transport and convenient to store. It should burn smoothly. It should have a high calorific value. It should not produce any harmful and toxic fumes during burning. It should not leave ash after burning. It should have a proper ignition temperature. It should not be too low like room temperature or too high. So harmful effects on the environment due to burning of fuels. So due to technological advancement and there is an increase in population, our energy needs have increased manifold. We are now burning more and more fuels. This increased use of fuels have several harmful effects on the environment. The burning of fossil fuels like coal, petroleum, diesel produces various air pollutants like carbon monoxide, carbon dioxide, oxides of sulfur, and nitrogen and unburnt carbon particles which causes air pollution. Fuels mainly contain hydrocarbons. So product formation of combustion depends upon the supply of oxygen. There are two types of combustion, incomplete combustion and complete combustion. So during incomplete combustion, carbon monoxide is formed. So when a fuel containing hydrocarbon burns in insufficient supply of oxygen, it leads to the incomplete combustion. And it produces carbon monoxide, water and energy. For example, incomplete combustion of methane produces carbon monoxide, water and energy. So carbon monoxide is very poisonous gas. If we inhale polluted air containing carbon monoxide, then this carbon monoxide combines with hemoglobin of our blood to forms very stable compound called carboxyhemoglobin. Due to the formation of carboxyhemoglobin, the blood cannot carry oxygen through various body parts, and this reduction in the oxygen carrying capacity of the blood leads to suffocation and may even cause death. So what is a complete combustion? When a fuel burns in sufficient supply of oxygen, it leads to the complete combustion and produces carbon dioxide, water and energy. For example, complete combustion of methane produces carbon dioxide, water and energy. Carbon dioxide released by the burning of fuel is not poisonous gas, but if excess of carbon dioxide is released in the atmosphere, then it traps more sun rays in the earth atmosphere. We know that the heating up of the earth atmosphere due to the trapping of the sun rays by greenhouse gases like carbon dioxide in the atmosphere is called greenhouse effect. So what is greenhouse effect? Heating up of the earth atmosphere due to trapping of the sun rays by greenhouse gases like carbon dioxide in the atmosphere is called greenhouse effect. The increase in the concentration of carbon dioxide in the atmosphere increases the rate of greenhouse effect. This leads to increase in the average temperature of the earth. This is known as global warming. So what is global warming? Global warming is the rise in the average temperature of the earth atmosphere. So what are the harmful effects of global warming? It affects the monsoon rains, causes changes in the seasonal pattern, causes excessive melting of polar ice, thereby raising the level of water in seas and ocean. This would cause flooding in the coastal areas and submerging of many low-lying areas. How sulfur dioxide is harmful? Burning of coal and diesel releases sulfur dioxide gas. It is an extremely suffocating and corrosive gas. However, sulfur dioxide dissolves in rainwater and forms sulfuric acids. How oxides of nitrogen are harmful? Exhaust of vehicles contain oxides of nitrogen which are poisonous. Nowadays, catalytic converters are installed in vehicles to convert it into harmless gases. Oxides of nitrogen combine with water to form nitric acid. The rainwater which contains dissolved oxides of nitrogen and sulfur is known as acid rain. So the rainwater which contains dissolved oxides of nitrogen and sulfur is known as acid rain. It destroys marble, limestone, metallic structure, plants and soil because it is corrosive.